Welcome. What we'll do today is present the work we did in the Chanel workshop. Do not ask me what Chanel means, but the first three letters refer to chat, and the last three letters refer to natural language. You'll have to do some twiddling on the letters for that. Okay, so let's start. So the basic theme of the workshop is trying to understand learning-based techniques for conversational systems. Conversational systems are different from, let's say, the ones we typically expect to find in ASR. You really need, what you're trying to study is a conversation between two people or between a person and a machine. And they're communicating because they have things to say to each other. We'll make one little distinction, which is dialogue, typically something that's in a well-defined domain, there's specific goals, and conversation, which typically is in social contexts, and there might be multiple goals, they're typically social. So these are really two different spheres. So the actual challenges that we're addressing is creating a speech-to-concept system that unifies ASR and NLU, basically speech to concept, or speech wave to concept, I should say. And the other bit has to do with creating computable metrics that indicate the state of a conversation. So I will speak a little bit about the metrics work, and Marcus Miller will then get on and talk about the end-to-end NLU work. So the main challenges for metrics and annotation is that well, there's two problems. One is we're not quite sure exactly what to measure, what makes sense. A human can listen, or one of us can listen to a conversation and sort of say it's good or bad, but that's really not good enough for the kinds of things we would like to be able to study. And part of the problem is we don't actually know precisely what people who annotate or label data should be doing. What has been found is that humans are expensive. You don't want to keep using them. So you want to automate these things. There are many different qualities to chat that need to be attended to. People have tried to get metrics from other fields like NT, but usually that hasn't been particularly coherent. It doesn't really work. And the general observation, which we all believe in, is that you really need to have objective metrics before, computable metrics before you start making progress and improving systems, comparing systems, and so forth. The other bit, which is probably self-evident, is to make progress, you need enough training data to essentially train models. So the state of the art in metrics is sort of, well, here's a set of properties that people have studied. Some of them are, like language variety, can probably be defined fairly well. But then there's things like coherence and engagement and so on that it sort of makes sense, but it's not really clear how to quantify those and turn them into computable metrics. Now, people have tried to do that, and some of the work in this workshop is to that effect, but there's still a lot of work that remains to be done. Basically, the way to think about it is that conversations, I'll just use the word conversations, are a sequence of interactions between two individuals. There's, well, here's a system and there's a user. And there are really three kinds of things we could be looking at. There's a holistic appreciation. Was this a good conversation or not? The evaluation of the current turn, either by itself or based on some kind of context. And with that, typically you have automated, proposed approaches have been automated in a sense that there is a target and some sort of reference for it. The current automatic evaluation work is really not very good in terms of agreeing with human scores. So here's one comparison between humans and blue. Doesn't look very good. However, humans seem to agree with each other. So there is something there that needs to be measured. We just don't have the right metrics for it. And there's a number of dimensions in which this has to be figured out. So in the workshop, we will talk about things that we did on assembling data, on trying out different modeling approaches, and trying to develop a general scheme for metrics. So that's it for me. And Marcus can now grab the screen.
Okay, yeah, thank you very much. So for the introduction, Alex. So yeah, as part of that JSALT team, we are also looking into, as Alex already pointed out, spoken language understanding. And when you look what people consider to be spoken language understanding, you see quite a lot of different tasks that are being summed up under that one specific thing. And I just pointed out a few here, and this list is by no means exhaustive. In this workshop, in particular, we're focusing on two things. So one is the intent classification task, and we are also looking into dialogue state tracking. Just to give you a brief overview of what are the components for end-to-end SLU systems. So I think when you talk about end-to-end, one of the things you first need to do is to define what are your two ends. So when we talk about an end-to-end system, one end, the input, is the audio, and the output in this case is the intent. And what the typical pipeline looks like is you have at the beginning some acoustic features, and then those features go into the SLU system, and then that system produces an output here, in that case, like turning on the light. What I've shown here is sort of a typical architecture that you see in literature. So basically, it is composed of two components. We have an ASR component that outputs transcript, and then that transcript is fed into the NLU component. So one of the downsides of such an architecture is that the transcript itself is not as rich as, let's say, the full speech signal. Therefore, some errors may be introduced by making that first hard decision very early in the stage. And also the other thing is that what people are typically do simply because of the data constraints, they train the ASR system on ASR corpora and the NLU system on NLU corpora. But those two corpora are sort of completely independent of each other, and that may also be one issue that could introduce errors. So speaking of errors, I just briefly wanted to point out, oh, that was one time too much. Okay, here we go. So in general, those end-to-end spoken language understanding systems, as you probably all know, all neural systems are very data hungry applications. And the architecture that I've shown you is mainly based on the availability of data. So typically, you would first train an ASR system and then add an NLU component on top of it. One of the problems there is when you build such an end-to-end model is that, for instance, the training objective for the ASR component may not result in the highest overall recognition accuracy of the SLU system. And to illustrate this, I've just made up an example here where those three different sentences have like the same word error rate, but in some cases the NLU can recover from it. In some cases it can't. Yeah, like when we hear we have a deletion on the on in turn on the light, then of course no one knows what should I do with the light. Should I turn it on or should I turn it off? Whereas when the is dropped, then of course turn on light still is somewhat recoverable. But also if like light is dropped, then that's also, I think, one error that is not very easy to recover from. Okay, let's see. Alex, can you go to the next slide, please? Thank you. Okay, so I just briefly touched on the problem with the available datasets. So, of course, there are plenty of datasets available for ASR, for NLU, for SLU. So really having the audio properly annotated to the intent. There are not that many datasets available, and those that are available are rather small. I don't want to go into the details of those datasets here because they will be explained in more detail further down the presentation. So just to give you a rough number, so if you have like 20 hours of data for the fluent speech commands, then you're really lucky. But that's probably definitely not enough data to properly train an end-to-end system to do that. Okay, Alex, next slide, please. Great that this spoken language understanding system here works, even though I have the impression it's like a Wizard of Oz experiment that we're doing here. Okay, so yeah, why do we want to build such an end-to-end system? I've already talked a little bit about this. So when we have the system, we have less explicitly modeled components, which means that we can sort of let the networks decide for themselves what is a good way to learn features. It may not be that the concept that we're using with combining ASR and NLU may be the best one to go. The other advantage is that by doing so, you can tie the components closer together. So when we go beyond such a cascaded system where we have the transcription as the interface between the components, when you move to a joint architecture, then you can think of other intermediate representations. So like some features in the latent space, which could carry a more richer representation of the input audio than just the transcript alone. And the second advantage is that you don't do a decision at the early stages in the pipeline. So for instance, when the ASR makes an error, it may be recoverable, it may not be recoverable. But when you carry over this richer set of features, then it may be easier to build a better system. And the last advantage of that is that you can also train all components on the final training objective. So you could pre-train individual systems, combine them, and then you can propagate the errors to the entire system architecture, which should then also lead to an improvement in the recognition accuracy. Okay, next slide, please. Okay, so before I hand it back to Alex and to the other talks, I just wanted to give you a big picture of what are the workshop goals for that topic of end-to-end SLU. First of all, we evaluated various model architectures on some standard data sets to see how well they perform. Basically having a look at the literature, what did other people propose, and do a comparison with that. Then another big problem is, of course, dealing with the dearth of data. So here we wanted to really bridge the gap between NLU only and ASR only datasets by looking into cross-model system training. And of course, when we look at what corpora for ASR, for instance, are available, we are also looking into pre-training. Then we also looked into going beyond single utterances, as in, can we build a context-aware natural language understanding system with the BERT by doing some dialogue state tracking. And last but not least, because the JSALT workshop is all about sharing knowledge, we worked on an end-to-end SLU recipe for ESPNet that we will publish, but please give us some more weeks because after this workshop ends, we have to do some code cleanup so that it's the recipe is more useful to you. That's it from my end. Yeah, Alex, back to you.
I was going to say, Marcus, you're going to work on that recipe and improve it for the next whole year, so no problem.
Okay, why don't we just move on to the first talk? So I think our speaker is available and actually has control of the, or will now approve the control of the slides. So please go ahead.